Hi YouTube, my name's Jeff and I'm the vegoilguy. If you've been watching my videos lately, you'll have seen my ongoing battle with lost wax casting. One persistent comment I've been receiving since starting is use a vacuum. Some of you have even been observant enough to say, hey, you've got a vacuum pump, why aren't you using it? Well, this pump cost me a lot of money, more than I wanted to spend if I'm honest, and whilst it's very good, it can't be exposed to heat, and molten metal is pretty hot stuff. So I wondered if I could make my own vacuum system, and that's what I'm going to be doing today. I started out with a couple of purchases, and I just want to begin with a big thank you to those contributors who've been kind enough to make donations. It really is a big help. I bought this solid stainless steel flask. It was a fifth of the price of the perforated flasks, so I thought I'd give it a go. I also bought this injection wax, and it's brilliant. Honestly, I can't praise it enough. If you saw the very first casting challenge, you'll remember I tried to cast a coin, and this is the silicone mould that I made. However, the coins I produced that time were far from ideal, but things were different with this wax. I poured some of the pellets into an empty food can and heated them gently on an electric hob until they'd melted. Then I placed a plastic syringe inside it to acclimatise. The wax isn't hot enough to melt the syringe, but if the syringe isn't preheated, the wax will freeze instantly. After a few minutes, a small amount of wax is drawn up into the syringe, and then it's injected into the mould. It's important not to pull the syringe out too quickly, but to give the wax a few seconds to begin to solidify. A few minutes later, the mould was opened up, and look at that. What an amazing wax pattern. This was my first ever try with this wax, and I couldn't fault it. I think these horizontal lines were caused by the force of the syringe, which to be honest was too large. A smaller syringe would have been much more easy to control. If you're wondering what all these lines are, they're tool marks from a 3D print, and I wanted to keep these tool marks. I wanted to test the ability of wax casting to pick up very fine detail. I decided to try this injection wax as a pouring wax. Even in an open mould, without any fuss at all, it produces beautiful results. Yes, I could have taken more time and got something even better, but for today's experiment, these will do, especially if we remember exactly what these faults were. I was so impressed with this wax that I honestly didn't want to introduce any other sort, so I made up my own crude sprues and then a wax tree. With a tree on an old tin lid, the steel flask slides nicely over the top of this, but to be honest, it probably leaves a little bit too much room, but better too big than too small. I surrounded the base with plasticine or modelling clay, whatever you want to call it, as this makes a nice watertight seal. I then mixed up some investment plaster, mixing this well for around 3 minutes in line with the manufacturer's instructions. I then vacuumed this into my vacuum chamber to remove any excess air. I poured the content into the tube and discovered that I hadn't quite mixed up enough. Typical. But this stuff goes off too fast to mess around, so I turned on my vacuum pump and removed any air that had been trapped during the pour. After it had set, which only takes about 10 minutes, I topped it off with a little more plaster to make sure that everything was properly covered. 2 hours later, I pulled the plasticine from around the rim, scraped away any loose plaster, then gently prised the wax from the lid. I loved the way it had captured the ink from the barcode beneath it. This was then placed in my foundry at 80 degrees Celsius for about an hour to gently cook out the wax. A few weeks ago, I shared with you a homemade vacuum chamber made from some cheap plumbing parts and bits of plywood. I wondered if I could use this to vacuum molten metal. Well, there's no way I could place a red hot flask inside a wooden box, but maybe I could place it on top of that box. I took the clear plastic lid and cast a silicone circle on top of this. Silicone is actually pretty good with heat, and can withstand up to around 300 degrees Celsius without any fuss. I drilled a hole centrally and planned not to lift the silicon, but the debris from the drill got stuck beneath this, so I had no choice. Though this type of silicon doesn't like sticking to anything, so lifting it was easy enough. I cleared the dust and realigned everything. Now I had somewhere to place the flask. I grabbed the handmade piston pump that I created at the same time as the vacuum chamber, and I hooked this up. I placed a food can on top of the silicon pad and got pumping. Almost immediately the gauge started to register the vacuum, and when I tried to lift the food can free, it was stuck firmly thanks to the power of vacuum. It's worth noting here that this particular vacuum chamber has got a small leak. Over around 20 seconds or so, it will lose vacuum. Now, whether this is the silicon seal, the valves or the plumbing, I really can't be sure, as the leak is so small I just can't detect it. But it does mean extra pumping to maintain the vacuum level. Additionally, this chamber is around 8 inches square inside, and whilst it's quick enough to empty the air, it could be quicker. So I came up with a simple solution. This is my lazy bucket. When I finish casting, I tend to throw in bits of plaster, metal and whatever other debris is left over from my day's tinkerings. I always keep my McDonald's drink cartons, as they make useful mixing cups, and 4 of these would be ideal for my next idea. I gathered the plastery debris and added some water to this, as I knew it would be thirsty for moisture. After a few minutes, I poured away the excess water, leaving a sludgy mess behind. I then mixed up some very watery plaster of Paris. A little plaster of Paris goes into the cup, then it's mostly filled with debris. Then I topped it off with more plaster of Paris and tapped everything to settle the content. Isn't it strange how it now looks like a McDonald's milkshake? Now these set within half an hour, and 4 of these fill my vacuum chamber easily. This drastically reduces the amount of air I need to displace. So with a lid on and a paint tin on the silicon pad, a quick pump test showed a much faster response. It was now ready to try with metal. Now, a couple of important points first. Firstly, the plaster flask was cooked according to the manufacturer's instructions, but this time I raised it to around 700 degrees Celsius. I then took this out of my foundry and surrounded it with fire bricks, allowing it to cool but slower than it would normally have done. Secondly, a few of you guys have been asking me recently about my metal preparation. So just to clarify, I do heat the metal thoroughly and I remove any dross. I then add a de-drossing flux and remove the dross again. After this I use soda crystals to degas. Some of you folks might not like that, but it was a tip I got from my footboy, and to be honest, it seems to help. After that I find I need to remove just a little bit more dross and then I'm ready to go. My metal was ready in my electric foundry. I placed the flask on top of the silicon pad and registered a temperature of around 100 degrees Celsius. I measured the temperature of the plaster inside and it was still a little over 200 degrees Celsius. So it's important to realise I have not maintained the flask at the same temperature as the metal, and I know that goes against convention. I took the crucible out of the foundry and poured the metal into the flask. It's around 700 degrees Celsius, nice and hot and a wonderful shade of pink. I quickly but safely put the crucible down and got pumping. Now did you see that? Let me show you again. Watch the metal as I begin to pump. It actually gets drawn down. You can see the metal visibly shrink. It's not much, but it is there. That's the power of vacuum. To be honest, I never noticed it at the time, as my eyes were glued to the gauge, and I didn't want to stop pumping until the metal had frozen. Once it had, which took a couple of minutes, I dumped the content into a bucket of water. Eventually most of the plaster was washed away, and I actually swore. I was genuinely taken aback. After a little more cleanup, this was the result. Now, if you're not as amazed as I am, I think you may be missing the point. These may not be the prettiest coins you've ever seen, but they are highly detailed castings, and they are virtually identical to the wax patterns that I made. There's no pockets, there's no porosity. Every flaw your eyes are detecting was also evident on the wax patterns. The vacuum chamber had done it. It had produced a near perfect casting, or at least as perfect as I can achieve. There are some strange straggly bits. Maybe there was too much vacuum pressure, I don't know. And on just one of the coins there's this strange pill-like flaw. It was so thin it could easily be ground away, and its shape is echoed on the other coin. Maybe there's a fault in the silicone mould, or maybe it's just because I've filled these two so casually, almost without a care. If you're wondering how all this vacuum business works, the pump makes use of two one-way check valves to draw in air in one direction only, creating a vacuum in the chamber. As there's a hole in the lid, this vacuum is extended into the plaster flask. Now, casting investment is specially formulated to be porous, so the vacuum sucks on the metal, or perhaps more correctly, the change in air pressure pushes the metal down. But let's not get caught up in science stuff. Let's just bask in the glory of these wonderful castings, easily achieved with a homemade PVC pump and a homemade vacuum chamber. Now let me tell you something even more impressive. Both the pump and the chamber were built for less than one of those perforated flasks would have cost me. And I could have bought 6 or 7 of those flasks for the money that I spent on my original vacuum pump. So here is a truly cheap, easy build solution for your lost wax casting troubles. Honestly, I cannot tell you how delighted I am with it. Sometimes simple really is brilliant. For details of this homemade vacuum chamber and also the pump, look to the vacuum chamber video. They're both very easy to construct. So it looks like lost wax casting has just got a whole lot easier for me. And one thing's for sure, you can be certain there'll never be anything small and detailed on any of the casting challenges again, because I'd be kicking backside. Talking of which, and that's the casting challenge, not backsides, we have a third challenger now. Big Stack D is planning to join our next casting challenge, which is going to be in early September. Both Perry and myself are looking forward to Big Stack's unique take on things, and no doubt the challenge is going to get even better. I can tell you now what we're going to be casting. It's absolutely brilliant. We'll all be having a go at casting, though the strawberries and kangaroo meat will probably be optional. And I think we can call that a finished video. Whee! I hope you enjoyed this one, guys, and if you did, please like it. If you haven't subscribed yet, then please do. Look out for my other videos on my YouTube channel and check out my website. So that's it for now, guys. Take care and thanks for watching.